Today, according to your past wishes, let's do some interesting work. The parts will be smaller than I usually make, it's harder, longer, but also more interesting. Purchased this little quartz movement, it's an ETA 980.163. And from the features it has the seconds hand brought down, 15 joules, which is pretty good for such a small size. Instead of a hand, there's a temporary plug here, it's only needed to keep the hour gear from falling out. Even though it's not mechanical, it's quartz, but even here the gears are all metal. You can see the quality in everything, well, made in Switzerland. In one of my past videos, when I remodeled a chess clock, the hands in order to shorten simply trimmed with scissors. It wasn't the best option, and a lot of people wrote about it in the comments. Like, it looks so-so, it's too big for that size, and so forth. Anyway, decided to tackle this issue as well. Today let's experiment with arrows. I have a few of these razor blades, and this is not an advertisement. It's just the thinnest I've found that's spring-loaded, and I think it'll work for arrows. Well, the first thing to do is to draw them, of course. First, we set the size of our mechanism and insert a picture of it here. Precisely adjust the dimensions, this will also come in handy for designing the dial in the future. We know the sizes of the hand fits from the description. They are 1.2 mm, 0.7 mm and 0.2 mm second hand. The picture was already with arrows, but I couldn't find them on sale, so we'll just repeat them for now. There's nothing particularly complicated here, just trace half of it, copy it to the other side and set the thickness. Do the same with the clockwise arrow. If the outer shape diameter is just an approximate diameter, then the inner ones are from the description. By spending a little time on modeling and calculations, quite a bit of that same time is saved in fabrication. Anyway, the models are ready, we can get started. The first thing we do is send our blade under the laser to cut the outline of the minute hand. If you don't have a laser, you can use etching, but in our case it will be faster. After cutting out the arrow, make 4 notches to make it easy to get it out of there. But before doing so, it is absolutely necessary to grind off the scale on both sides. While the process is underway, I'll share a great joy with you. Finally, another laser came to me, but of a completely different type. It has a beam 3 times smaller than this fiber optic, and it can do things this one can't. I will show it to you in the near future and tell you what I need it for. Cut at low power for 600 passes, but the scale still holds the arrow in place. The metal is thin and you have to carefully remove everything to avoid breaking it. This is how the arrow turned out. Now we need to make a footer for it. It's a tiny cylinder with a hole in the center that holds the arrow. The footer will be brass. Brass is soft and will consequently expand slightly when put on the axle. We grind outwards to a diameter of 1.3 mm, then the arrow seat with a diameter of 1 mm. Drill a hole in the center, but not all the way through. The hole diameter should be 0.7 mm, but the drill bit is actually a little thinner, which is good, it will be a tighter fit. Try on the arrow, it should not dangle, but it should not go in tightly either, otherwise it will simply tear. It's fine, you can press all the way in. Now we need to cut off our fungus. Cut not immediately above the arrow, but 1/10 higher. The cutoff cutter was made from an ordinary 0.5 mm thick stationary knife, but even that was too much. In general, grooved still and on slow feed cut off, otherwise the arrow can just roll. Now the arrow needs to be ground on the backside. To do this, unfold it and glue it onto the tab. We hone the remainder of the cutoff cutter and sand a little. Brass will tarnish anyway, and tarnish not very nicely, so we pattenize it right away. The arrow was glued on cyanoacrylate or supercline. To remove it, dip it in acetone for a while. While the acetone is doing its job, we'll make the second hand, the hour hand. Pretty much the same here, just a lot less ring thickness. The inner diameter here is 1.5 millimeters, and the outer diameter is only 1 1/8, respectively. The wall is 1500s thick. Try different options. You can just sand it down, it will be a bit matte, or mirror polish it. I managed to shoot this arrow too, so that's how it turned out. Meanwhile, the minute one is peeled off, you can take it out. Yeah, I know a magnetic tool shouldn't be, but kinda like quartz isn't as critical. Overall, the patination is in question, either polish harder or look for more options, but the gloss of the arrow itself is good. The watch founder will be different. Firstly, the landing of the arrow on top, secondly, the hole is through hole. It has an outside diameter of 1.7 millimeters and a bore of 1.2 millimeters. Ideally, you should drill a smaller diameter hole and then finish with a reamer, but you'll probably have to make the reamer yourself. In this case, drill without the centering drill bit. Just feed the drill slowly at the beginning and wait for it to find the center. We sand the workpiece, degrease and also patinate. Remove any remaining fluid and try on the arrow. Here the tension should be even less because the walls are thinner. We also fix it in the plane. And you also need to sand the arrow end because it's a little rough after the laser. You can't see it with the naked eye, but still. Next, cut at a distance of 1.25 millimeters from the top. The height of the footer should be selected depending on the future dial. The thicker the dial, respectively, the higher the footer. It was time to put it all together, but I made one big mistake here. You can't do that. The hand should be mounted either on the dial or the gear wheel should be placed on a hard surface. Although I didn't bend anything this time, but still, mistakes should be taken into account. After that, set the minute hand. Again installed this temporarily and without a spec tool, just to check. Considering the small size, it turned out kinda nice, but there's still a lot to experiment with. Specifically painting the arrows blue on a glowing copper plate. Try making arrows out of titanium, it can be oxidized to almost any color of electricity. Cut out original arrows, for example, with a chess piece on the end. In general, there is still a lot of work, experiments too, but I think everything will work out. Here, however, much of the work has been left out, but most importantly, the wolf is not as scary as it is painted. Bye, I'll see you soon.